So super excited to be here and talking to so many great projects. And to begin, I guess, if you guys all want to introduce yourselves and what you're working on, and more specifically, how it relates to these themes of decentralized storage and CK.
Sure thing. So I'm Christopher. I work on a project called Anoma, which is a distributed operating system for intent-centric applications. And these are, let's see, how many buzzwords does this tell? I laugh. Decentralized, trustless systems. I don't know what that word means at all. Zero knowledge and case studies. And I'm woefully underqualified for any panel on case studies because I'm working on a system that hasn't even been launched yet. So, I could give you some theoretical case studies. I would say one aspect in which Anoma really touches upon these questions is in dealing with applications which work on the basis of intents. We have to think about privacy and data in sort of two phases always. What we call counterparty discovery, which is say if you have an intent to swap A for B and you want to find someone who wants to swap B for A, or two people, B for C and C for A, you need to discover your counterparties, right? And settlement. And privacy and settlement is what, let's say, just the blockchain applied CK research community is thought about most thus far. But unfortunately, or fortunately, if you're into theoretical case studies, privacy and settlement is the much, much, much easier problem. Because once you know what your transaction is, once you know what your state changes are, you can basically just make a zero knowledge proof of it and post it to some blockchain and you're done, and the privacy is fantastic and you don't need to worry about complicated trade-offs. But counterparty discovery, by its nature of wanting to discover counterparties, requires that you reveal some information. So here, the kind of trade-off space of privacy and data and, where is your information going is much more complicated. And we spend a lot of time thinking about that.
So, hi everyone. So I'm Alexandre. I'm from Linea. So for those who don't know Linea, it is what we call a ZK VM layer 2. Essentially, what's called a ZK rollup. So it is a platform that works essentially as Ethereum. So it's an Ethereum, like an Ethereum private network, to which you can submit your transaction. And upon processing the transaction, the operator of the network, it is a centralized network for now, but I'm going to talk more about decentralization later, bundles all these transactions and generate a proof for that and publish it on mainnet. So we've been live for 1 year and a half now on mainnet. And on average, to give some number, when we send one proof on L1, it verifies 65,000 transactions. So that's a big payoff in terms of scalability. And this allows us to have 1 cent transactions as other projects. And so in the future, we want to decentralize the sequencer. But that's not really related to zero knowledge, so I'm not going to talk too much about it. But I think this is still very important for censorship resistance, but we also want to decentralize the prover. I think that would be interesting for the case study. And I'm working on the zero knowledge part of it.
Yeah, I'm Kai, or Kieran. I'm contributor to more historically, a number of different privacy protocols. Currently, and for the last couple of years, contributor to RAILGUN. So we go through the list of keywords there. Decentralized. So RAILGUN is a private transaction system built on using ZK, zero knowledge proofs, that aims to be or minimize the additional trust assumptions or decentralization or security assumptions that you take on over the top of using, Ethereum or whatever other chain that you choose to use.
Great, thanks, guys. So I think the first question should be a kind of spicy one. So what are the biggest myths or misconceptions around any of the stuff in the space that you would want to myth bust? So this is basically just an invitation to be kind of salacious and be everyone has this thing wrong. Here's how it actually is.
Right, okay. I'm just going to take the title. So the word decentralized is, interpreting it charitably, it's a nice investigative direction because as you discover new centers in your systems, you try and decentralize them, you learn things. Interpreted literally, it's meaningless because a system that is decentralized has no centers, therefore there is no data anywhere, it's impossible. if you interpret it quite literally. Something like polycentric or having many balanced centers, or drawing more on classical political theory, trying to have multiple centers of power at roughly the same level is a much more, I would say, pragmatist approach to what kinds of systems you can actually build and what kinds of dynamics actually matter. Trustless, the way the control of computer systems works, either you have a computer that's physically within your control, and then you don't really need to trust it, because at least in principle, you can read the memory cells and figure out what it's doing. Can be difficult. TEs are kind of an attempt to make that impossible, or at least quite tricky in practice. But any computer that is not physically within your control, if you are in any way relying on it in the course of some operations, you are, I would argue, practicing some kind of trust, or at least in your action, you are committing to some kind of trust. So I think rather, trustless is like, half good intentions, half marketing, but it has this unfortunate effect sometimes at obscuring what it is that you're actually trying to do when you design systems, because there is no such thing as a trustless system if there are multiple participants. The only kind of trustless system is where there's one participant who controls everything and they don't have to trust themselves, but this doesn't really seem like what we want, right? So I think heterogeneous trust, or reasoning about dimensions of trust, which is not a unidimensional thing, and complexity in how to update your model of who to trust in the system based on the interactions you actually have. This is a much more useful frame. Zero knowledge, that term, at least in the cryptography literature, is fine, but then it got repurposed to mean succinct, which I find endlessly confusing.
I was going to say that most of the time, a lot of projects, including myself, I'm really one of the main culprits here, use ZK to say that or zero knowledge to talk about their project. But in reality, zero knowledge has a precise meaning, and it involves privacy. It means that you prove that you know something without revealing anything else than what you prove. So there is this idea of privacy. But this is absolutely not what we should do at Linea. So for ZK, so it's about what we call succinctness, essentially. So a more correct way to denominate what we do would be snark. And snark means that you have a proof. The proof is short and it can prove something that is huge, but it has nothing to do with privacy. But since anyway the proof is very small, it does not reveal anything interesting about the transactions.
Yeah, I guess the ZK naming also kind of irks me. You're like ZK snarks. Like, why did you choose the half of it that is not? Like, I guess like snark rollups don't sound as good in marketing material. Yeah, maybe to just like echo what's already been said a little bit. Like decentralized and trustless as well. I think like these are like terms that like get thrown out a lot. But, at some level, you're always going to have, it's a spectrum, right? And you're always going to have like a little bit of trust or a little bit of centralization there. And it's, I think really what we mean by this is more, giving the ability or, the possibility for people to push the verification, in the terms of like trustless, and push the decentralization as much, as far along that spectrum as possible. Can I involve the audience a little bit here?
Yeah, go for it.
Okay, hands up if you've actually gone through the process of like an open source app that you use and actually verified the code yourself. Cool. Okay, we got some hands. Keep your hands up if you've verified the operating system you're running it on. Okay, cool. So like we're killing at that stage. I didn't have to go all the way down to the hardware level, right? So there's like a little bit of trust in there, right? But the idea of like building these things which we call decentralized and trustless is not about like absolute decentralization, absolute trustlessness. It's about having the capability for people to verify if they need to or if they so choose.
Great. So I think like now that we've kind of like debunked the buzzword aspect of this, do you guys want to talk more about like the points at which they are meaningful, or at which like any of these concepts guided your work, and some concrete examples where it's actually been implemented and you feel like aspects of your work or maybe even like other projects are doing something like meaningfully decentralized or trustless? No?
All right. So on our experience, so decentralization is something that we really we are pushing forward and that we want to really deliver. And the more we talk about it, the more complicated we find it is, because having something that is decentralized, I'm thinking, for instance, about the prover means that you better be really sure that there is no some back in the prover, because otherwise the prover becomes meaningless. But of course, we need to do that anyway, because otherwise we are nothing more than a proof of authority or private blockchain or private blockchain. I hope that Linea can be more than that. But there is this part, but there is also concretely how you do it, because when you decentralize and you start including decentralized protocol, when you have different parties that have to be that don't trust each other, and you don't want them to trust each other because you want to protect your participant, and you want to emulate something, and putting it's already hard in itself. I mean, I think a lot of people here may agree with me, but when you add ZK on top of that, it's, I believe, even harder.
Yeah, I guess to me, a useful first step when trying to investigate what trust means in the context, or trustlessness means in the context of decentralized systems, is to try and classify or taxonomize a little bit the kinds of services and kinds of trust that we're talking about into broad groups. Like just thinking about distributed networks, I usually think of four: compute, ordering, storage, and network relay. And this taxonomy I find useful because there's a different degree of kind of trust that's always going to be required or possible to remove in each of these cases. So compute is a really easy one because you can just verify it later with at least a succinct and a possibly zero knowledge proof, right? So if someone does compute, you need to trust them with any data that might be necessary to do that compute. But once it has been done, pretty much anyone on the network, asymptotically, assuming you have someone making the proofs, can verify it afterwards. There's no sort of long-term trust required, and the trust is very scoped. Storage is different because storage always involves some amount of trust for LIHES, or so-called data availability, that you can send data to someone, and whatever you do, if you send a message to them in the future asking for them to send that data back to you, you can't force them to send it back to you, right? You're always engaged in a certain amount of trust. You can try to distribute that between multiple parties. You can store copies of the data, shard it, erasure code it, but that fundamental trust for liveness is always there, just sort of perhaps differently organized. Ordering, you're always trusting someone not to double sign. If you want to delegate ordering to a third party, typically a blockchain with a distributed validator set, you're trusting a quorum not to double sign. And, some of the boundaries of that trust depend on how interoperability works and other things, but there's always this basic sense in which if that quorum, or even if it's just one node, if it's one sequencer or something, chooses to double sign, they can break property that you care about in your system. Network relay we don't talk about very much, but it's still pretty important. Luckily, you can verify it after the fact as long as you have signatures. If you ask A to relay to B and you get a signature later from B, it proves that they knew about the packet that you sent, and you could check this. So that one, again, there's trust for the relay, but you can at least get a pretty good feedback mechanism afterwards.
I think maybe talking a bit more on a practical example, but hopefully a lot of people in this room have used, right? Just talking about DeFi. We'll say I've got some super mega giga awesome lending protocol, right? And it says that it's 2x over collateralized for the loans that it gets at, right? On the topic of being able to push that decentralization and trustlessness boundary as far as possible, right? I don't think, like, if you told me that you've gone through and verified every single DeFi protocol that you've ever used, if you're a regular user, right? I'm gonna call BS on that, right? But the idea is, like in the case of this lending protocol, right? It says it's 2x over collateralized. I look at what the outstanding loans are, right? I look at the vault contract on Etherscan, right? I can see, it has $1 million in loans. Does it have 2 million collateral, right? At least. And that's a very simple way for someone that maybe doesn't have a ton of technical skill to be able to go in and verify it, right? If you look at the equivalent of like a TradFi system, maybe there's like some finance nerds in the audience here that know how to read all these like reports and where to find them, and I don't know, maybe these like reports are only published like quarterly or whatever, so you're like, I'm delayed by up to 3 months, right? that same property doesn't exist. And the barrier to or the skill barrier and even the access barrier, right, is a lot higher. And so I think when we talk about DeFi or the decentralization DeFi, right, we're not talking about this, again, absolute decentralized, you've verified everything and it's all perfect system. It's about being able to push that boundary to the point where if I need to verify it, right, or if I need to verify someone else's claims that is compromised, right, this is probably a more important one, it's much simpler and much more accessible for me to do.
Great, thanks, guys. Also, just one quick technical point: the clock reset during that convo, so I can't keep track of the time anymore.
Yeah, I was wondering, whoa, what happened to my memory? It's all the way back.
Okay, cool. So another, I guess, maybe not the latest, but an invitation to debate something is to what extent do you guys feel ZK is a kind of final point, and do you see it as being in competition with other types of cryptography like FHE and MPC, and are these things kind of co-collaborators or competitors, and how would you contextualize that?
So I think all of these technologies, right, there's a tendency for people to just throw them out there as a checkbox. It's oh, we use ZK, right? ZK for what, right? It's about the, I think when it comes down to when you're building applications, we need to think about what are the properties of the actual application that you want, right? Although if you send over a bunch of checkboxes and again, marketing material, maybe it looks good. But in terms of actually delivering value, right, I think the use cases that you're targeting need to inform what your architectural decisions are. So there's going to be all these trade-offs with MPC and all these other technologies, and I certainly think ZK, especially when it comes to certain applications of privacy and the significance properties, can be particularly useful. But I don't see it as a direct competitor to MPC and all these other things. I think it's a matter of you've got a large toolbox, you got to pick the tool that's fit for purpose.
So I could not agree more with Kieran. People, I have also seen a lot of discussion where people are between no, MPC is better than ZK, no, it's FHE. So indeed, these are really different tools, and depending on your program, you won't plug a screw with a hammer. You need a screwdriver for that. I mean, I'm sure. And so, for instance, for what we do at Linea, there would be no way that we replace the snark without ZK being non-abusive of the terminology this time. You would not be able to replace it by an MPC or FHE. It would not work. It would not be any helpful. MPC, for instance, is especially helpful when you have a group of people that each knows some part of some secret or some input to some computation. Say, if everybody wants to, we want to know the sum of the salary of everybody in this room. I'm not going to ask anybody what their salary is because maybe they would like to keep this private. But an MPC would be a way to collectively collaborate to evaluate this number in such a way that we know nobody lied. So it's great. We can solve a few problems like that, but we won't solve blockchain scalability with that. But it has immense potential in cryptography. And FHE can have also a lot of application in ZK machine learning. I'm sure this is going to be amazing at the end. And one last point, so there is something, so there is what we call indistinguishable obfuscation and witness encryption. And these are theoretical cryptographic primitive that we call ultimate. If you know how to do that, and we don't know how to do that, you can do everything. You can use it to implement ZK, you can use it to implement MPC, everything. You do everything with that. Hopefully it happens one day, but I don't think so. And it probably won't be as efficient as the technique we have today. Or maybe it will be, but it will take 1 century before we develop the right techniques.
Can I add a little spice to this? All right. So I think if the selling point of what you're building is if you focus on like, oh, we're using this particular tech or this like academic paper or whatever, if that's a selling point of what you're building, right, and your argument is, oh, this is just categorically better, without talking about what properties it gives you, right, which benefit the use case you're targeting, and how those properties are better than the alternatives. If you're not talking about that, then you're not building anything useful.
I agree with that spice, by the way.
Yeah, I think like this is mild on the spicy scale, and we need to, at least in this room, I feel like the challenge is, at least that I've been thinking about and not making a lot of progress on recently, is the reason I can't speak as to Linea, but I suspect that the reason why the word zero knowledge is used in many more contexts than like a strict reading of the definition might justify is because it has become a way to do capital formation. Zero knowledge is understood, for better or for worse, by many people as like a category of things you can invest in, which is a little bit weird. Like if you translate the metaphor to cars, zero knowledge is like, I don't know, the composition of the aluminium in your like drive pipe, right? Like it's like investors saying, oh, I want to invest in this car company because they use 3-methyl aluminate. Where's your 3-methyl aluminate play? Yeah, wonky. But however, that happens because there's like not a clear, I would say at least not a clear way to taxonomize and classify systems by their user facing purpose in the way that you're looking for, or at least not a clear way which has become actually sort of understood and embodied in the consciousness of our collective consciousness of our ecosystem. So I think I'm curious if people have ideas there.
I mean, are we just like scared of building actual real world user facing things? Like we're just stuck in this imaginary infrastructure land?
I think maybe yes. I think there's like, I don't want to derail this, but I think there is like a fear in the industry of actually like putting stuff out there that will be like tested and might be found to be like vulnerable or maybe not engaged with. And I think like infrastructure feels safer in some ways. But not in all. There are like real world use cases emerging. But yeah, I think as well, like it's interesting what you said about like ZK just becoming like a tool that people use to get more funding. And are there other ways in which you feel like these terms are possibly misleading or maybe even dangerous? Like if you just whack ZK, the title ZK on a project, like does that sometimes lure people into thinking it's more private than it is, or that something's like safer than it is? Sorry, that was off script. We become a question.
No, I do want to know, the conversion of the word zero knowledge from a property of cryptographic systems used in some academic papers into a meme that managed to raise a lot of venture capital funding and plow it into applied cryptography research, like I consider a success for the world, right? And now it came with trade-offs, and the trade-off is some semantic pollution. But on the other hand, the applied cryptography is really useful. So, I'm not, there's this like interesting calculus there, right? I wonder even if we can do, where are the witness encryption focused venture capital funds? Where are the, maybe it's you. I want to see more of that, right? ZK is kind of
the next best work.
Yeah, it tends to be very, everyone like copies each other. It's a very Gerardian world, at least here. So, we have lots of funding going into ZK. We've exploited all the marginal low-hanging fruit. We need to route it elsewhere. I veered off your question, I'm afraid.
No, I love this answer. I think it's true. It's like a good Trojan horse. Like privacy was traditionally really hard to get funding for, and now like ZK's in.
Right. It also doesn't sound privacy. It's just like a word that everyone, especially in the US, runs away screaming from. And zero knowledge sounds arcane and technical and less likely to land you in jail.
Airport. Yeah, I mean, I guess like, I'm assuming we're all fairly technical here, and so the naming of like ZK being thrown over these things is going to irk us a bit. But I think I agree as like overall as a whole, words don't need to language kind of evolves, right? Like words don't need to, in common parlance, strictly stick to what the technical definition is, right? It can be fluid. But I think the danger occurs when it's as long as the terms used don't lead people to believe that something has a property that it doesn't, right? So you can say, I don't know, you can say like ZK. Everyone thinks it's private. Maybe it's not. Or even you can say something's private, but private can mean a lot of different things, right? Like, it can mean a certain aspect of the system's private. There's all these things, right? So as long as the users understand the properties of the system that they're using, I don't necessarily have a problem with technical terms not necessarily matching up with how they used in wider systems.
So on my end, I'm not too afraid that the ZK word might become too misleading to people and might become dangerous. Essentially because in the way it is used today is, from my perspective, it's too seduce VC. In a lot of for a lot of projects, not every project. There are many projects that actually build things, push the boundaries of science, develop new techniques, and do really cool stuff. But if you think outside of the planet blockchain, nobody has any idea what ZK or zero knowledge means. It's still very niche, very popular in blockchain, but it hasn't reached the consumer, the mass consumer market. If you say to a random person in the street, "Oh, here is this pasta, there is zero knowledge in it," it's like, but yeah, I mean, obviously I'm taking a silly example, but I don't think it would work with any application. People understand privacy, so that might have value to people, and it might also irritate the American government and also the EU regulation.
Well, this one I want to challenge a little bit because I think the word that creates by far the most misunderstandings, including ones that matter sociopolitically, is privacy. Because privacy in common parlance has this association, especially in English, of an act of hiding, right? You close your curtains. I think privacy comes from a world of light. If I want to hide from this light, I need to put my hand up to block it. I need to engage in some purposeful action in order to block something. And when you read, for example, when you read draft U.S. legislation, often it appears that the people writing that legislation think that privacy protocol means that a privacy protocol hides data from the government. This is false, right? The only thing that a distributed system can do is give you control over what data you choose to reveal to whom. And the only thing that so-called privacy protocols can do is give you more fine-grained control. When you use Ethereum, your choice is either you reveal that your transaction to the entire world, or you don't send it at all, right? It's not, you have kind of this very binary choice. When you use something like Zcash or Railgun, you have a much more fine-grained choice, but you could always reveal the information that you know to anyone you want to, including if you wanted to, a regulator or somebody you wanted to prove something about your activity to. So I think that word is pretty dangerous. And we have, Web3 privacy, for example, I love that group, and they have awesome t-shirts. And we're a supporter as well, but I worry about some of the consequences of trying to popularize this word and popularize the technology associated with this word. It's a very cypherpunks tend to be, let's define privacy, redefine privacy. Privacy means freedom. Privacy means, privacy is the freedom to reveal yourself to the world or something like this. There's some nice definitions of it. But the problem is that this is just a bad tactic in large scale political discourse. It's much better to build the actual technology that actually protects people and call it something like, I don't know, information flow control or data protection, which the European Union will be very happy about now. So,
I mean, yeah, I guess I can go off and state that my use of technology tends to be very private, right? And if I go and explain this stuff, what does that mean? Oh, you're weird. What are you hiding, right? But if I actually explain what I'm using this for, right? I have don't know. I'm assuming, everyone here has multiple ways to contact them, right? Some are public facing. Maybe you have like an email address on your like, if you have a personal website, or like you posted in some like bio somewhere, right? And you're quite happy for that to be, out to the world, and anyone can kind of reach out to you on that. And then maybe you've got like different methods that like, it's just friends and family sort of thing, right? That can reach you on that. And, I would be very, very annoyed if, the ways that I talk to friends and family suddenly just got inundated with a whole bunch of spammers and, like phishing attempts or all these kind of like things. Privacy is important to me just for my own personal sanity. It is psychologically healthy to practice, good privacy hygiene.
Yeah, it's really interesting. I think like on this topic of using ZKs for filters, I've noticed a real trend, like a good trend of projects using those filters in the space to build social apps that are like designed for better connection, because you're not spammed and you can have controls over like who sees particular types of information and have like better quality discourse convos. And it's not this like antisocial blocker that it's like often confused as being. Anyway, we've got like 3 minutes left. So instead of a question, I was going to ask, is there anything any of you guys want to say just like on this topic that you didn't have time or like a chance to say whilst we were having the conversation? Do you want to show your products?
I want to highlight a point that I've brought up a few times, and I've had the two of you also bring up as well. Cool, it's all well and good to rather build infrastructure and all, but please, like we need actual, end user, like real use cases, applications that people can use, because talking about this nebulous ZK pasta, whatever, just like, where's that going? The only way to actually affect change is to build stuff that people can use.
So guys, you've also been given another 10 minutes as well. So, I mean, like, why don't you guys, if you did have any statements you want to make, you can still make them, and then we can see if that sparks a debate, and if not, we'll go back to the questions.
I have a question to you actually. Can you tell us now about the use case, especially how it works out in Russia?
Yeah, sure, thank you. Yeah, so like I mentioned in the beginning, Rarimo released a tool called Freedom Tool, which supported surveillance-free voting. So it used passports and passport CKPs. It was super easy to use. Like, you just take your passport, you scan the NFC chip inside. It's actually a little bit more complicated. You didn't just like straight away get like a ZKP anonymous voting pass, but like we use zero knowledge, and then you get an anonymous voting pass, and you can cast your vote, and the vote itself is published onto blockchain, where of course it's tamper-proof. And the first use case was in Russia, so it got picked up by a guy called Mark Fagan, who is a opposition activist, not an opposition activist, just an activist. And he is the former Pussy Riot lawyer. And his kind of vision for this tool actually, so like long term, it was to create a parallel voting system. But much shorter term, it was to try like understand how dissidents in Russia are actually thinking and what they want from the people that are seeking to support them, because the communication channels were just so broken down that was very difficult to do. So they were like, okay, let's use anonymous voting as this kind of like quite blunt like feedback mechanism. So he launched an app called Russia 2024. And the first referendum that was held on it was on whether or not the official elections were legitimate. And we had over 40,000 votes and over 25,000 downloads in the first 24 hours, which, like, for a social app in Web3 broke records. There was like a lot of challenges around deploying it. The Kremlin didn't like it, so it was attacked like several times in like a myriad of ways. And one of the like strangest forms of attack, I think, because it turns out the Kremlin have this like cabal of state-sponsored app reviewers that they had like systematically just tank the ratings on the app. But messages were sent like to Mark and the team that were running it from the app reviewers being like, please keep this up. We've been forced to do this. Like, we really need anonymous voting. And actually, I think the fact that it was attacked so vehemently actually really boosted like trust in the tool. And obviously, like, you know, you get 7-year prison sentences in Russia for protest and even just using this parallel system, even if you voted, say, like in favor of the Kremlin, would be seen as an act of protest. So we didn't expect like the whole of Russia to use it straight away, but I think the fact that like it has been used, it has been publicly attacked, and it has survived, and the people that used it haven't been persecuted, is building trust in the tool. And I think, interestingly, this kind of goes back to the theme we were talking about, or I think like Kai mentioned, of like the end or the borders of trustlessness, because actually like there was a huge amount of like trust, and the people that used this AMP did it because they trusted Mark. They can't read code. Most of them were actually like normal people. It wasn't crypto native people at all, which I think, talking about like ZK, is very exciting that we're at that stage with like ZK where you can do like client-side proving and all this stuff that just makes it like super easy to use. But yeah, it was actually like sort of the whole use case was a testament to like the boundaries of trustlessness and applied trust lies. And then after that, it got used by dissidents in Iran. So again, like the trust from Russia. And then we most recently had our first use case with elected officials, which was opposition MPs in Georgia used it to run tampon polling there. And anyway, I could like talk about it for quite a long time, but I don't want to take up.
I mean, 45 minutes into the panel about case studies, and we finally found a case study. and a brilliant one, it sounds like. I'm curious, one, this is awesome. And two, how did you communicate this app? Like, did you set out to build an app for Russian dissidents to vote? Or was that sort of what you found as the initial kind of people who would really benefit from this technology? And how did you, I guess, find or communicate to, especially Mark?
Yeah, so like we can't talk in too much detail about like, yeah. But we're based in Kiev, so our team is Ukrainian. And when we started building Freedom Tool, we had all these different contributions from a lot of cryptographers, especially in like Russian speaking communities, and also a lot of cryptographers, particularly who heard about it and were in regimes and they wanted to contribute. And so word just spread very quickly that there was this tool, and different activist groups like became aware of it. So I'd say like roughly that was how it got out. And then in terms of like, do you mean like how we communicated with groups, or more like how they then communicated with the users on the ground?
I guess, I mean, how did you communicate what the tool did and what it used the technology for in a way that kind of made it clear to people that this was providing a kind of privacy that would help protect?
Yeah, well, so it's interesting because like we just don't go into the tech, like whenever I'm talking about it, like whenever like it's CK, kind of what you were saying, like if you go up to someone on the street. So like it was always just emphasizing like what this tag actually does, like being like, do you want to hold surveillance free voting, like yes or no? And then obviously like once like you kind of lure people in, like us, like with that you can then talk about the tech and like explain it, and people of course want to make sure it's robust and like believe in it and stuff. But yeah, like the tech was not the selling point. The use case was the kind of the value was. But yeah, and I think also like in the process, this is maybe like swerving a bit, but just to like show off. I'd say like in the process of building it, we discovered like a lot of problems with pre-existing privacy infrastructure. So I mentioned before, like we got rid of third-party attesters because we realized like that whenever you're using like even an MVC, there's a chance that the specific action that the user is like using the app to generate their proof for can be linked to the MVC. So we like rebuilt the protocol, and now we have no third-party attesters. Users publish a nullifier of their passport on chain, and then they generate proofs of inclusion like on the chain. So it's impossible to link like what action the user is taking to the action, and like it could be for anything. It could be for voting, or it could be for like meme coins, and even in like the worst case scenario, someone got a hold of your passport, they wouldn't be able to figure out like exactly what the user was using it for. So I think like as we started developing it as well, like once we started working on it, there were all these technological advances that then made the protocol like even more attractive, and sort of like overcame even like the kind of most obscure challenges that existed like in the beginning. But yeah, that was
That's an amazing project.
Thank you. And also, I would just say as well, we have lots of different sub-registries, like passports is one. We support like other identity types, also permissionlessly. And we have like a ZK reputation sub-registry that we're really building out at the moment. So if that's like of interest to anyone, like please find me and we can talk afterwards. Yeah, but we still now have 3.5 minutes. Which means I guess we have time for another question. Oh, sure. Okay, Q&A. Does anyone have questions from the audience? Okay. So I guess that is the end. Unless you guys have anything else that you want to say or add. Or like if you want to talk about use cases on any of your projects.
We went to the end. One question?
So it's a boring question. Maybe somebody could have Linea. If you could tell us about your tech stack from the bottom up and what
Bottom up, so starting from the
started the operating system upwards. Tell us a little bit what it is and how you've optimized maybe Linux or whatever you're running it on. Maybe some of the challenges you met along the way and how you got rid of this. Thank you.
So we start from so it's running on Linux. In reality, it's running on a Kubernetes server, but in practice, you're not too impacted because I'm talking about the proof of code. It is super CPU intensive, and the overhead that you might have by running on the containers usually happen when you have like many containers on the same machine and so on. Here we just have a container on one machine. Then we run a binary executable. It's written in Go, and most of the time critical functions are written actually in assembly. We are going to transition to a specialized implementation using AVX 512 for efficiency. I mean, the goal for us is to reduce the cost of running the program so that we can decrease the transaction cost. That's the explanation. So now software. So written in Go, as I said, we developed our own proof system and we implemented a framework that automatically compiles the specification of the VM into custom proof system. The proof system is so automatically generated. That's I think one of the first. It's common when we describe a proof system in the academic literature to describe it in this way, but we actually implemented in this way. So it's not just academic. It is like 500. It contains dozens of thousands of variables and equations that are verified, proven, and so on. We are glad that this is automated. We are using lattice cryptography as a basis for our polynomial commitment. So we also use a random oracle model. And so that's how the proof system is implemented. So it gives us a first layer of proof generation that takes a lot of transaction and compress really fast, but with not very good compression ratio. And then we have another proof system that does a tight compression ratio, but is slower, but runs over free contract data. And then, okay. So yeah, be at the present time.
All right. Yeah, I think we need to wrap it up. Thank you guys very much. That was awesome.
Thank you.